All right, so 7.4, solving logarithmic equations. So solving log equations, use the definition of logs to solve, right? We're looking for x. What does x equal? So remember, a logarithm literally is just the exponent. Just a little review, if I would have something like log 416, how would I go about and solve that? Equals y, and do a little circle of magic, a little circle of magic. So you start at the base, 4, and you point to the exponent, to the y is equal to, and then you point to whatever that number was, result, 16. So what number would go here? So I picked an easy enough problem that we know that, like, oh, 2. 4 squared is 16, all right? So I'd put 2 there. You know, another way we would solve it is rewriting 16 in terms of 4 to some power. And remember, if we have the same base on both sides of the equal sign, that means the exponents must be the same as well. So I find the exponents too. Okay. Yay, nay, yeah, okay. So let's go through and let's solve this problem. So log base 8 of x equals 4/3. First step, rewrite it in exponential form. So I start at the 8, point at the 4/3, and then like go to the x. So I have 8 to the 4/3 power is equal to x. How would you propose that we solve this? Do we have any ideas?
You multiply by 3 over 4
Well, I already have x by itself. This is what you guys want to do all the time, and I'm like, no, use your brains, but this time you can do it. Yeah, use your calculator. Heck yeah, how would you put this in your calculator? 8 to the 4 divided by 3. So it puts it to the 4/3 power. And then our solution would be 16. So this is like way 1. You can do it with your calculator. You know, I nice to you guys. So I let you use your calculator for the test. I just want you to show your work. So for instance, this part right here, and these arrows, like the part I highlighted in green, that's what you would have to show for work. The arrows show me you know how a log works, how to move it to exponentials, and then the 8 to the 4/3 power equals x, it shows me how you set it up and put it in your calculator, and then you wrote the answer. So the reason I want to see partial work, I want to see work is so I can give you partial credit. Because if you enter it wrong in your calculator, I don't know, like I want to give you as many points as possible. All right, the other way to solve it is 8 to the 4/3 is the same thing as saying the cube root of 8 to the 4th power. Well, we know the cube root of 8 is 2, and then I do 2 to the 4th power is 16. Whatever. This is another way to solve it, but I'm going to let you use your calculator as long as you understand how to use it, show the setup, we'll be grooving. All right, so let's try the next one. Am I good to move over? All right. So I have log base 16 of x is 5/2. So you start at the base, point at the exponent. Remember the exponent's what it equals with a logarithm. The answer is the exponent. And then I'm going to be pointing at the result. So 16 to the 5/2 power is x. So once again, you show the setup, you can put it in your calculator, 16 to the 5 divided by 2 power. So this is going to give you an answer of 1024. I want you guys to try it. Try plugging this in. So I'm going to give you 30 seconds now. Get out your calculators. Practice plugging this in. That way you know how to do it on your test. You have your calculator? Noah. It's fine. I'll show you the other way to do it in case you want to do it by hand. So this is okay. I'm gonna tell you one of the differences between intermediate and algebra 2. Intermediate, I just let you use your calculator for this. As long as you know the setup, I'm good. Algebra 2, they want you to do it this way. So you have the square root of 16 to the 5th power. Square root 16 to the 5th power. Because this is the same thing as 16 to the 5 seconds. It's the same thing. Square root of 16 is 4. And 4 to the 5th power is 1024. 1024. I'm good with the pink. I'm good. Alright, so we practice plugging it in. Now for the second half of the lesson. Property of equality for logarithmic functions. So we kind of like covered this already. So up here, what allowed me to set the exponents equal to each other? Why? Why could I just say, oh yeah, well, y is equal to 2? Because they have the same bases. Awesome. Okay, let's go down here. As long as it loads. Okay, guess what's happening here? I have log base 4. Log base 4. They have the same bases. So, since they have the same bases, I can set what we're taking the logarithm of equal to each other. So I can set the inside parts equal to each other, as long as I have the same log base. So that's why I highlighted. They both are log base 4. Cool. And you only can have like one log on both sides. If there's like, over here, if it's like, oh, plus log base 4 of x, you have to like fix these first before you can like set the logs equal to each other. So tomorrow's lesson is how we would fix it. Yeah, that's a good question. That's a good question. Tomorrow's how we'll fix it. Okay, since we have the same base, I'm going to set what's inside equal to each other. So x squared equals negative 6x minus 8. I want to solve for x. Have we done a problem like this before? Yeah, so how should we go forward? Do you have an idea? Factor first, move everything on the same side. Then we'll factor it out and solve for x. Okay, so I'm going to move both of these over to the other side by adding 6x on both sides, adding 8 on both sides. So that way I have x squared plus 6x plus 8 equals 0. Alright, so I moved everything over. I got everything on one side, said equal to 0. Now I must factor. So this is taking it back to chapter 4. How do I factor these? So they add to 6, multiply to 8. Talia, did you say? Exactly. So 4 and 2. If I add them, you'll get 6. If I multiply, you get 8. Okay. So I have x x plus 2 times x plus 4 equals 0. I'm done. Aha, I factored it. But it's not the answer, right? I'm not actually done, right? I factored it, but I'm trying to solve for x would be equal to. I have to equal x. I have to solve for x. So I'm going to take each one of these, set equal to 0. So x plus 2 equals 0. Subtract 2 on both sides. I see x is negative 2. So I see two possible answers. X can equal negative 2 or negative 4. But I need to actually check my answer. I need to see, will this actually be true? Because remember, remember how we graphed exponential functions and they look something like this, either growth or maybe they were like decay. And we had an asymptote at the x-axis. We did not have any y values below the x-axis unless we had a transformation of a function, right? If we shift everything down. But there's literally, when we have exponentials, there's literally a line where there's no y values underneath. So what this means is you can't take log of a negative number. You can't take log of a negative number. So my example for this just to show you that this is true, what if I have log base 4 of negative 16? Well, normally when we would solve it, right, we would say, okay, that equals y, so I have 4 to the y equals negative 16. So what power would you put 4? Do you put 4 to what power is 16? Is negative 16? Well, if I put 4 squared, that's positive 16, right? So that's my point. You cannot have a negative number like that you're taking the log of, because there's no exponent that would give you a negative. Right, so I proved it to you. Can't take log of a negative number. So if I plug in these x values into like the inside portion, like I can't have it be a negative number in there. Okay, so I'm going to check my answers. I'm going to check negative 2. So I have log of negative 2 squared equals log base 4 of, oops, I forgot the 4. Let's see, negative 6 times negative 2 minus 8. So log base 4 of negative 2 squared is 4. Log base 4 negative 2 times negative 6 is 12 minus 8. Okay, so inside here, 12 minus 8, is that positive or negative? Positive. Okay, so my negative 2 checks out. That's fine. But I also need to check my negative 4, because what happens if my negative 4 has it be negative inside here? What happens if it's negative inside there? And it won't be one of my solutions. It'll be extraneous. It'll be extra. I'll cross it out. I meant to check negative 4. So log base 4 of negative 4 squared should equal, so I'm plugging in, I'm seeing if the inside actually turns negative or not. Negative 6 times negative 4 minus 8. So I have log base 4 of 16. Can you guys see this? It's super, I'm sorry. Equals log base 4. Negative 6 times negative 4 is positive 24 minus 8. Okay, so this will be 16. That's fine. It's positive. So both of these are fine. So I'm showing you how to check, because guess what? In our next example, spoiler, well, we're going to have one that doesn't work. Okay. So this is about, like, I know it's a lot of work, but as far as the problems for today go, this is about as hard as it will be. It's not too bad. It's like factoring. Notice how we're using like chapter 4, 5, 6. Like everything builds on each other. All right, if you're done, try working on example B. All right. How do I even go about solving this? Like, this is crazy. I don't know. Is there a trick? What is the trick, Noah? Yeah, since they have the same base, I'll set them equal to each other. So x squared minus 10 equals 3x. Then he said bring it over so I can factor it. X squared minus 3x minus 10. All right, if I factor, I want to know what adds to negative 3 and multiplies to negative 10. Negative 5 and 2. So I have x minus 5 and x plus 2. Alright, so down here I see x is equal to 5 and x is equal to negative 2. So I found two possible solutions. I need to go through and check them and make sure that when I plug in the x value, this part I'm highlighting in green, the inside portion, if that turns negative, that means this actually is a fake solution. It's not going to be a real solution. So let's go through. So I'm going to be plugging these in. Let's check 5 first. Check x equals 5. So I'm not like doing out the whole problem. I'm just saying, okay, does this return positive or negative? So log base 5, 5 squared minus 10. log base 5, 3x. Oops, 3 times 5. So I have log base 5 of 25 minus 10 equals log base 5, 15. Okay, so I see on the right side it's positive. What about on the left side? 25 minus 10? 15? Okay, so that one's fine because I end up with a positive number there. Because I'm not like trying to go solve it. What I'm trying to do is make sure I'm not taking log of a negative number. Okay, now I'm going to check x equals -2. Log base 5, -2 squared minus 10 should equal log base 5, 3 times x, which is -2. On the left side, I have 4 minus 10. On the right side, I have -6. Uh-oh. Can't have a negative there. And 4 minus 10 is going to be a -6. So even though the left and right side match, that's not what it takes to get it kicked out. Right? So I can't be taking a log of a negative number. So that means x minus 2 is not my solution. I only have one solution, and that's x equals 5. That's the only solution I have. Okay, so we are going to, so am I good to move this? No, a little bit. Okay, I'll zoom out a little bit. Kind of hard to see. So this down here, this is going to be an extra credit assignment because I'm going to show you what we're actually going to do for homework, and we're going to do it all together. So this extra credit, the homework is going to be this handout that we're going to get started together. If we finish your homework in class, groovy. But this is an opportunity for you to apply it. Since it's such a short lesson, we're going to be going through some problems like together. We could finish the actual homework, and then this gives people extra, a little bit of extra credit and also a chance to do more practice problems. Okay, so while you guys finish writing this out, I'm going to pass out the other thing. Yeah, there's 18 problems, and we could actually get through all of them. And literally, like, there's a graph that you use to get bonus resolution points. This is so sparse. Ooh. Yeah. Didn't know the TVs were on. That's good. All right. All right, so let's go through this. All right, so we're going to do yeah, let's do it. Do you want to come up and do it, or do you want me to just write what you say?
Whatever you want.
Okay. Let's do it. All right. Yeah, you can tell me what to write.
Okay, so you move it to draw the arrows.
Sure, I'm gonna draw the arrows.
Draw the 2 to the 3x and trace it down to then do 2 to the 3x equals 32. And so you want your bases to be the same. And so you do 2 to the 3x equals 2 to the 5th. And then you equal your exponent. Then you get x equals 5.
Exactly. All right. Cool. So I'm gonna stop the recording.